Alright, so this is part 2 of 3-1 graphing polynomial functions. So we just finished talking about is understanding end behavior in the 4 types: odd degree, even degree, positive, negative. So let's do an example. Determine the end behavior of each polynomial function. Starting with A, f of x equals 2x to the 6th minus 5x to the 5th plus 6x to the 4th minus x cubed plus 4x squared minus x plus 1. So when we're determining the end behavior of a polynomial, you need to look for 2 things: the degree and the leading coefficient, and then we can use those to determine the end behavior. So looking at this equation, we should be asking ourselves, what is the degree? Remember, that is the highest exponent, and in this case it's obvious because it's actually written in descending order. So the degree is 6. Now we need to figure out what is the leading coefficient, which I'm just going to write LC. The leading coefficient is going to be alongside the degree, and that's going to be 2. Now what we care about is the degree even or odd? So 6 is even. And then the leading coefficient, is it positive or negative? This is positive, which means our end behavior we should be thinking, okay, degree is even, so that means it's either up, up, or down, down. And since the leading coefficient is positive, it's going to be going up. So our end behavior is up, up. And we're done. We got the degree, the leading coefficient, and therefore the end behavior. Let's look at another example. G of x equals negative 5x cubed plus 8x plus 4. So again, we need to ask ourselves, what is the degree? And we can see that it is going to be 3. That is the highest degree. We ask ourselves, what is the leading coefficient? That is going to be negative 5. So degree, leading coefficient. So because the degree is 3, that means it's odd. You should immediately be thinking different directions. And then the leading coefficient is negative 5, so the fact that it's negative is what's important. So the end behavior so you should make a little coordinate plane. The end behavior is therefore, if it's odd, it's going to be opposite directions. And if the leading coefficient is negative, it's going to end going down. So that is going to be up, down. And that's it. So knowing degrees, knowing our leading coefficient, understanding end behavior is helpful for graphing. So what we're going to do next is sketch a graph from a verbal description. So given the description, sketch a graph. So let's get into the description. So we're going to be given 4 things. First thing is the function, or f of x, is positive on the interval negative infinity to negative 4 and negative 1 to positive 4. So positive, remember, is above the axis, the x-axis. So another descriptor, f of x is negative on the interval negative 4 to negative 1 and 4 to infinity. So the function will be below the axis during this interval. F of x is decreasing on the interval I guess we should have s's intervals for all of these. Negative infinity to negative 2.67 and 2 to infinity. And finally, f of x is increasing on the interval negative 2.67 to 2. Okay, so all of this information put together tells us 3 different things, and that's going to lead us to the actual graph. So one thing that it tells us that's going to be really important is it tells us the x-intercepts. So the first thing we should do is identify them. Let's say identify the roots or zeros. So then we don't have to write them as a coordinate point. So if we're going to identify any roots or zeros, that's going to be based on positive and negative intervals. Because remember, a positive and a negative interval, right? Positive is above the axis, negative is below the x-axis. So if something's positive between negative infinity and negative 4, that means that it's going to go through the axis at negative 4. So we can conclude our roots and zeros are going to be x equals negative 4 from here, x equals negative 1, and x equals positive 4. Another way to conclude it is just from the negative. So again, we've got negative 4, negative 1, and 4. So that's when it goes through the axis. Now we can identify our turning points. Well, a turning point is going to happen when it changes direction, right? If we go like this. So when it's decreasing to the point it's decreasing at will be a turning point, and then when it switches to increasing, it's going to show us another turning point. So we're going to have turning points when it's decreasing, so if it's going to turn at negative 2.67, which we can confirm again here, and then again at 2. So it'll turn when x is negative 2.67, and it will turn again at positive 2. Now the last thing we can figure out is the end behavior. Now we don't have the equation, but we can look at when, again, it's increasing and when it's decreasing. So if we go back up, okay, it's positive from negative infinity to negative 4. Bam, end behavior. From negative infinity to negative 4, well, that means that it's going to be, where's my pen? That means it's going to be coming down, right? We make ourselves a little coordinate plane. It's going to be coming down, it's going to be positive until it gets to negative 4. Then we can also see it's going to be negative over here when we're going to infinity, so that also helps. The infinities are what we're looking for our endpoints. So it's going to end going down, because from 4 to infinity, it's negative. So with the combination of all of these three things, we can set up a graph and sketch one relatively accurately. So the y-axis isn't going to matter so much. The x-axis will, because we know our roots, which we need to plot first. So I'm going to have a scale going to 4. Sorry, I'm going to have a scale of 1 going to 4 and negative 4. And then I'm going to plot my roots. So we wrote down negative 4 as a root, negative 1 as a root, and then positive 4 as a root. Now my turning points, I'm going to highlight. So our turning points were around negative 2.67. So here's negative 2. I'm going to go a little bit past. So I know that like my turning point is somewhere over here at that x value. And then I know my other turning point is at positive 2. So I'm just going to highlight vertically at positive 2. And now I'm going to try and draw my function. So starting with the end behavior, because we know it's going to start by going up, well I guess decreasing, right? It's decreasing from negative infinity to negative 4. I said that wrong. It's positive from negative infinity to negative 4. My apologies. And then it switches from decreasing, starts increasing, right? And then we know it's going to turn again over here. I probably turned a little too early. So we have 2 turning points. Check, check. We went through each of our roots, and then our end behavior is accurate. And that's it.